This is lesson 9.5. We're going to talk about hyperbolas. The hyperbola is the last of the conic sections that we're going to talk about from chapter 9. And it comes from when you have the cone shape. And here's my beautiful cone. If you slice the cone at an angle, but through the base, then when you look at the cross section, it looks like kind of like this. So when we do a hyperbola, we actually have two of the shapes, and they're always opposite like this. So when you have a hyperbola, you have two basically parabola type shapes. But it doesn't fit exactly the same as a parabola. So we're going to look at some things that are different. First of all, we have a formula that's similar to an ellipse but slightly different. And the part that's slightly different that's very important is right there. It's the subtraction sign. So x squared over a squared minus y squared over b squared equals 1. The subtraction makes it be a hyperbola instead of an ellipse. Some things that are going to look familiar. We're still going to have our center. Our center is still going to be the origin like it has been on everything else because we are just introducing this. The center to one of the, like from the center to here, that A measures to the distance to the vertex. And then if you measure going this way, the measurement we're going to do for B, well, you're not going to be able to see it too well on here, but what we're going to do is we're going to use it for constructing our shape when we go to the next video slide, which is going to be where we graph. So we're going to have A, which goes always to the vertex. We're going to have B, which goes away from the vertex. And then you're going to have C, which goes from the center all the way to the focus. So C this time is longer than A, whereas with an ellipse, C has to be smaller than A. And in fact, when we go to find C, C squared is going to be A squared plus B squared, which is the same as the Pythagorean theorem. So a hyperbola is the set of all points in a plane such that the difference of distances to two fixed points, called foci, is a given constant. So it may be hard for you to tell what they're talking about here, but if we pick a point on the actual hyperbola, and then we measure it to the focus, and we measure it to the other focus, and we subtract, then we're going to have a given constant. So let's say that constant was 4. Well, if we picked a different point, and we measured the distance to the focus and to the other focus, and we subtracted these two distances, then we would get 4 again. So that's not something that you have to remember. It's just useful math information. Okay? So let's talk about a horizontal hyperbola. How do I know that this is horizontal? Well, a squared and x squared are first. In the ellipse, we look to see where a squared was because a squared was always bigger. But in a hyperbola, a squared is not necessarily bigger. So whichever comes first, so in this one, x is the first variable and y is the second variable. Whichever comes first tells you which way it's going to be. So this is a horizontal hyperbola because x squared is the first variable in the problem. So let's look at an example. I have x squared over 9 minus y squared over 25. Because of the x squared being first, that's going to make this be horizontal. It has nothing to do with the denominators. Now a squared is going to be 9. Because it is first. And b squared will be 25 because it is second. Okay? So this is all based on the fact that the first denominator and the first variable that you come across, it's not which one's bigger this time, it's which one comes first. Okay? So if a squared is 9, that means a is going to be 3. And if b squared is 25, that means b is going to be 5. So I have 3, and I have 5, and all of my centers are going to be at 0, 0. And c is going to be found by doing a squared plus b squared. C squared equals a squared plus b squared. So c squared is going to be 9 plus 25. So c squared is going to be 34. So C is going to be the square root of 34. So I'll put the square root of 34 over here. Now the vertices are always going to go with A. So since this is horizontal, this will be at 3, 0, and back that up, negative 3, 0. And the foci are going to be in the same direction, but they're going to be a little bit longer. So let's see what the square root of 34 is. It's about 5.8. So the foci are going to be at 5.8, comma 0, and negative 5.8, comma 0. Okay, so I'm going to go and graph this. This can be in the next slide, so if you need to pause and make sure you have all this information, now's the time to do it. Otherwise, we're going to go on, and I'm going to have 3 and 5, and it's a horizontal hyperbola. So since it's horizontal, I'm going to go 3 first to the right and to the left because that's A. And for B, I'm going to go 1, 2, 3, 4, 5 up here. 1, 2, 3, 4, 5 down here. Not the best in the world. Now if this was an ellipse, we would take these points, we would connect them and make an oval. But since this is a hyperbola, we're instead going to draw straight lines through the dots. Well, let's try it again. I'm just doing some bad drawing here. Straight lines through the dots that create a box. It's going to be a rectangle. Okay? And when we have this box, then we're going to draw a line that goes across the center and through each end point of the box. So across the center and through each end point of the box. Okay? And what this does is it gives me guidelines. Now remember, this is horizontal, so the vertex is here and here. This is the point on the right side is 3, 0, and on the left side is negative 3, 0. We wrote these on the previous page under vertices, or the two vertexes. Okay, I'm going to take that out there so you can see what else I'm doing. So there's my vertices, and I'm just going to use the shape of the lines as guidelines. So my hyperbola is going to go way out towards these guidelines. That's my hyperbola. That's all we had to do. We did the A, we did the B, we made a box, we made a big X, and then we used the vertices to draw the guideline. Now I also need to put my focus in here, and the focus is at 5.8, so 1, 2, 3, 4, 5.8 is like right in here. Just kind of guessing. 1, 2, 3, 4, 5.8, it's close to 6. So there's going to be a focus here and there's going to be a focus there. Again, it's not really part of the graph, but it is something that's important in terms of a hyperbola, because things that are hyperbolic are kind of like, if you think of a satellite dish, and then on a satellite dish it has kind of the center spot where the signals, like signals bounce in and they come to the center spot, and they bounce off of here and they come to the center spot. So the focus is an important thing, it's just not important in the process of graphing it. Okay, so let's look at a vertical hyperbola. What's different? Well, this time y is first. And since y is first, it's going to be vertical. A squared is still first. So a squared is not based upon size. It doesn't have to be the biggest denominator. It's always the first denominator. Everything with a hyperbola is first. Other than that, we still have our center that's going to be at 0, 0. You still have a vertex here and here, and it's a distance from the center. That's the vertex. You're still going to have a focus here, and that's C distance from the center. And then the B distance, now you have seen, the B distance is what we use to create that box that makes our graph. Okay? Other than that, we just know that if it's a vertical hyperbola, our shape has to curve up and curve down. So let's look at the example that goes with this one. So y squared is first, that makes it vertical. A squared is 4 because that's the first denominator. B squared is 16. That means A is going to be 2. That means B is going to be 4. So what do I know here? I know the center is at 0, 0 because they all are going to be at 0, 0. A is at 2, B is at 4. C squared is A squared plus B squared. So C squared is 4 plus 16. So C squared is 20. So C is the square root of 20. Which is close to 4.5. Okay, remember that A tells us our vertices. Since this is vertical, this time now the 0 is going to be first, so it's going to be 0, 2. And it's going to be 0, negative 2. Same thing with the focus. It's going to be 0, 4.5. And it's going to be 0, negative 4.5. So that's all the information that we need, and now we're going to go to the next screen and we're going to graph it. So I have A is 2, B is 4. Alright, so I'm going to go 2 up and 2 down. Now I'm going to go 4 right and 4 left. So A is up and down, B is right and left. I'm going to try to draw a really good rectangle this time, so you can kind of see what's going to happen. Okay, now we're going to go, oh, bad drawing. I did good until right over here. Okay, let's try it again. Now I'm going to go through the edge and through the center to the other side. These things are actually called asymptotes, and we had asymptotes on the rational functions we did not too long ago. Basically, an asymptote is just a guideline. It kind of guides us and tells us this is what your graph is going to do as it grows. So our vertices are going to be up here. Let me switch colors. Up here and down here. So through the vertex, following the guideline, through the vertex, following the guideline. There's my hyperbola. And then my focus was at 4.5 about. So I'm going to go to about 4.5 as close as I can to 4.5 up here. And so that's my hyperbola and that's my focus. Focuses or foci. That's how you graph a vertical hyperbola. Now the process was not any different, it's just that this time we knew it was going to be vertical, so when we drew the shape we knew to go upward and downward instead of being over here or over here. So that's how you do that. A couple things to remember as you get started on your assignment. When you talk about a hyperbola, only with hyperbolas, C is going to be C squared equals A squared plus B squared, and in the hyperbola only, A squared is always first. A squared is always first.